Okay, so we are going to be doing some quotient rule examples in this video. I'm going to follow the same procedure as last time, and I will be providing some full examples as well as some questions with just the answer for you to try on your own. Now, you'll notice for this particular example, both the derivative of the numerator and the derivative of the denominator is equal to 1. So you're going to have to listen very carefully as I calculate or how I'm calculating so you don't mix up the formula. So the first thing I'm going to do is take the derivative of the first function, the top function, which is the derivative of x is equal to 1, and I'm going to multiply that by the derivative, or just by the original bottom function, which is x plus 1. Now I'm going to take the derivative of the bottom function, which is also 1, and multiply it by my original top function, which is x. And all of that is going to be over the bottom function squared. So it's going to be over the original x plus 1 function squared. Now at this point, I'm going to expand using derivative property. So 1 times x plus 1 is obviously x plus 1. Negative 1 times x is negative x, all over x plus 1 squared. So that means that h prime of x is going to be equal to 1 over x plus 1 squared. Notice, because the numerator is very simple, I can keep the numerator as 1, and I don't have to, there's no need for factoring the numerator. Therefore, the denominator also does not have to be expanded or factored. So here we have our top function, a numerator function, as 2t minus 3, denominator t plus 5. Again, we start with h of t, so I need my derivative to be written as h prime of t. And we're following the same exact formula. So the derivative of my top function, 2t minus 3, would be 2, multiplied by my original bottom function, t plus 5. Subtract that with the derivative of the bottom function, which is just 1, multiplied by the original top function, my numerator, which is 2t minus 3. And all of that is going to be over the bottom function squared, so t plus 5 squared. So I have h prime of t is equal to 2t plus 10 minus 2t plus 3, so negative 2t plus 3, all over t plus 5 squared. Now, right away, I know that my numerator is going to have a constant number, because this 2t cancels with this 2t, and then I have positive 10 plus 3. So my final answer is going to have 13 in the numerator, h prime of t is going to be equal to 13 over t plus 5 squared. Okay, so I'm going to give you a second to tackle the next question. And I'm going to solve this fully with you. Now, you'll notice on the top for the numerator, we have a cubic function. So we know the derivative will become a quadratic function. In the denominator, we have a quadratic function, so we are expecting a linear function for that derivative. And you can always feel free to calculate your derivatives first. I'm just going to plug everything directly in, so you can always pause the video and kind of check my derivatives that I'm calculating. So I'm going to, again, h prime of x is my derivative. I'm going to take the derivative of the top. So I have 3x squared multiplied by my original bottom function, 2x squared minus 1. Pause this for a second. Okay, now for the second part of our formula, we're taking the derivative of the bottom function. That would give us minus negative 4x. And we multiply that by the original top function, x cubed, all over the bottom function squared. Now we're going to have some higher order polynomials with this example. So h prime of x, don't forget that part on the left-hand side is equal to 6x to the power of 4 minus 3x squared minus 4x to the power of 4 all over 2x squared minus 1 squared. Now, still, we don't have a function in the final numerator that we have to factor, so we can leave the denominator the way it is. H prime of x is going to be equal to 2x to the power of 4 minus 3x squared all over 2x squared minus 1 squared. Okay, the next example is quite simple. So I'm going to just provide the answer here so that you can try this on your own. And so the answer to this very simple function is h prime of x is equal to negative 2x over squared plus 3 squared. For the next example, it might seem a little complicated, but this is another question I want you to try on your own, because we can turn this into a very simple function by expanding the numerator and the denominator. So my numerator is 3x squared plus 5x, and my denominator is 1 minus x squared. So when you try this on your own, you're going to get the final answer of, we can say dy over dx, or y prime, for dy over dx is equal to 5x squared plus 6x plus 5 all over 1 minus x squared over 2. Now, x squared minus, 1 minus x squared to the power of 2. Now, notice our final solution in the numerator does not have a greatest common factor, so we can't take that out, nor can we factor it. So we're going to leave the function the way it is. You're going to see that for the next example as well, but I'm going to go through the next example step by step. So we have a quadratic function in the numerator and a quadratic function in the denominator. Well, let's go ahead and solve this. So dy over dx, derivative of y with respect to x, that's how we define dy over dx, is equal to the derivative of my numerator first, 2x minus 1, my top function, multiplied by my original denominator, bottom function, x squared plus 3, minus the derivative of my denominator, 2x, multiplied by my original numerator, x squared minus x plus 1, all over my denominator squared. I'm going to give you a second to actually expand and use your distributive property.